All right. Hey, everybody. So I'm here to do the bronze recording for the USACO 2022 contest. So I guess without further ado, let me just get started. Oh, wait. Sorry, I have to connect my, I'll connect this while I'm doing my problem reading. Okay. So anyway, yeah, let's start the contest. Okay. Right. Okay. So let's just look at the problems first. The first one is Herdle. You guys can read this. I'm just gonna set up my mouse and stuff. All right. Okay. Pattern of the breeds in field. There's 26 possible breeds. Okay. Hmm. Oh, I see. Okay. The number of yellow hides required indication of the number of cows of a certain breed. For example, suppose the gas contains 4 cows of breed A, the gas contains 2 cows of breed A. I know. Okay. I think we can just start with this problem. This one's really weird because the input's kind of tricky. Like I want to make sure. Ooh, sorry, didn't mean to do that. I want to make sure that I get this problem right. So I print the number of green squares numbers. So cow say moo when the IOI. Oh wait, also I have to do this. It's in core. No, it's here. Yeah. Slideshow. Start. Okay. So here's my scratch pad. All right. So cow say moo when the IOI. So cow. Actually, I do like this. Cow say moo. And then the guess. This is the correct one. The guess is in black. When the IOI. So the green squares are gonna be. Can I have it green? No, I don't think so. Can I color it green? Can I do this? Here are the green squares. And then the yellow ones, I guess, are the ones where, what am I looking for? So you want to guess the yellow ones are when, suppose the guess grid contains 4 cows of breed A, the answer contains 2 cows of breed A, where none of the A's line up. In this case, only 2 of the A's in the guess grid should be colored yellow. Oh, I see. Okay. Wait. So where's the yellow square here? It's in the guess grid, right? So cow say moo. So W is in the wrong place, so it's yellow. There's no I's in the answer grid. There's no N's. There's no T, no H, no E. So I guess this is the answer. That's why it's 1-1. I think what this input is trying to tell us is that, sorry, let's go to a new page. Pen color, just do black. So if I have like in the answer grid, if it's like A, A, A. And the guess grid, it's like A. There's like 4A somewhere, and they're not in the right place. Well, that means that these A's here only count for 3 yellow squares because there's only 3 of these. If this A were here, like overlapping, it would cancel out. So these 2 would cancel, and there would only be 1 yellow. No, there would be 2 yellow A's actually instead of 3. So yeah, I see. I kind of understand how this works now. I think the way I'm going to implement this, I'll have an array for each letter A, B, C, D, E, F, all the way to Z. I will store the guess, amount of times it showed up in guess, and then the amount of times it showed up in actual. And I'll also, and then I'll loop through the entire array, right? Go through like every index, ij. If they're equal, I decrement 1 from guess and 1 from actual. So what that'll do is at the end of this process, if I don't know, in actual there was like 5, and guess there was like 2, right? So that means so we got rid of all the ones where so let's say this is for A, right? There's 2 guesses of A and 5 A's in the actual. And then initially there could have been like 3 and 6. But what if we found like an AA here that canceled out? So this represents the number of incorrect guesses, and this represents the number of like actual A's that don't line up with like the guesses. So because of this contributes 2 to the yellow. So using this process will calculate for the greens, but for the yellows, we'll use this table to calculate. So I'll just code that up. So I'm going to do this is int guess count. Oh wait, no, this is array of size 26. Count is also size 26. And then we'll do oh, this input's weird. This is funky. But we'll do char actual, and then this will be 3 by 3, and guess is 3 by 3. So we'll just do, so for int I equals 0, I is less than, this is reading input. We first read the actual one, right? Okay. I guess I'll do this. Line for like every line of input. And the line, and then we'll do string char at string at. Can I also use? I must use the j equals 0. Actual of I equals. I don't know if I can do. I'm gonna try something. So this one. So we'll just read in a line. These are string arrays now. And I think it'll actually work out. 2, 4, equals 0, plus. Well, I'm okay. So this is the character indexing, I think. I don't know why I is purple. I should not be purple here. What do I need to do with this? Actual count of this minus this big A symbol. So this is a trick to get a character into the format of a integer. So let's say this is like B, right? B minus the character A will give you 1. What? Actual count. Oh my goodness, it even knows what I actually meant to say. That's really smart. Yeah, I mistyped it. So let's say this is like, I don't know, let's say this character is C, then C minus A will be 2, which is a good index for where C should be. Yeah, and then we'll do the same thing here. Except we'll do replace with guess. Yes. And we can also do something here, right? Wait. Did I do actual count and then deny? So weird. Me too. Okay. Then we can also do this for int. And then oh no, wait until after we read them both in. Now for int. I'll just copy this double for loop structure. And then we'll do oh sorry, not Google Chrome, green, yellow. We'll do this. If what's wrong with this? No, I don't mean discount. Oh, I just need to say it. Okay. If actual at ij is equal to guess of ij. So this is something's in the right place, right? Green plus plus. Oh no, there's a lot of stuff to do actually. So green plus plus, and then guess count of guess of ij minus a. This needs to be decremented, and then for actual count, the same thing, I think. So I just copy from here, actual ij. Okay, and then I equals 0, I is less than 26, I plus plus. If how does this work? I think we'll take the minimum of the guess and the actual, and that's how it'll work. Because if you guess 4 of them, there's only 2, then only 2 should be highlighted. So yellow plus or equals to the minimum of actual count of I, and then guess count of I. So now we have to try to, and then see out green, yellow. And is that right? Do you do the green first? Yeah, okay. Just try this with some inputs. So we'll run it. Oh, build filled. Oh, I didn't put a semicolon. Whoops. Hello. Oh wow, it took me so long. What the heck? 1-1. Okay, that worked. It just takes forever to build. 1-2. Okay, nice. I'll just try it, see if it works. This is my wrong folder. Desktop, Star, USACO, January, bronze, main. Okay. If this is wrong, it's gonna be a pain to debug because I really don't know where it could be wrong. Okay, thank goodness it seems right. Okay, great. Okay, so that's that problem. It's a contest. Now what I need to do is take this, save it in problem 1, and then clear the main. I'll clear later. All right, non-transitive dice. So the passage time counts as a dice game. Wins game played 2 dice, both the roll and the winner dies the number showing. If both land on the same numbers, they're re-rolled. I see. Okay. If dice X beats dice Y, it's more likely that X will win the game than Y. Okay. 6. C also beats A. Wow, that's very cool. I didn't. That's a really cool thing. Just like not even USACO. That's really interesting. What? I think that's cool. Non-transitive set of, non-transitive set of 3 dice. What's non-transitive? Is that what they defined here? Oh, okay. 1. Each dice beats 1 other than 1. Give the numbers in face of a 2-sided die. Okay. Wow, this is like a math problem. So the first line contains T, the number of test cases to solve. Each test case describes one case in terms of 8 numbers. The numbers of 4-sided die A, the number of 4-sided die B. How do you make a 4-sided die? Oh, it's like a pyramid. Okay. all numbers 1 through 10, not necessarily in sort order, the same number may appear multiple times on the same die. Okay. I'm wondering if I can just brute force the number, the same thing, right? T lines are not the GS is times. I can brute force and stuff like that. Is there a way for me to tell? I can brute force this problem. I think this is there. The question is there a way to see if A beats B? So there are 4 things, right? What I can do is, that's not 4 spaces. So that's the question I'm trying to answer. I'm going to erase this now. So if there are 4 possible things dice A could be, and 4 things dice B could be, to see if A beats B, we can enumerate all of these and then see win or loss for all of them, right? And then if the wins is greater than loss, then dice A beats dice B, I think. Okay. So what we can do then is for each, it's in sorted order, right? So we can do a kind of brute force where we try for dice C, every possible dice C, and see if there exists any dice C that can beat A, B, and C. So let's write the brute force. It's going to be a little bit bad, but it's going to be a little bit, not bad, wordy to write, but it's really not too bad. Okay, so first step, first things first. I'm just going to define int n, and then and then we can do like dice A, and then this is a 4 size array. Dice B, it's a 4 length array. And then we'll do dice C that will fill out. It's another 4-sided array. And then we'll define a method actually, bool beats dice A array int dice B array. For int I equals 0, I is less than 4, I plus plus. This is like the method to determine whether something beats something else. For int j equals 0, j is less than 4, j plus plus. So W int W equals 0, int L equals 0. So win and loss. We don't really keep track of the draws because as long as the wins are greater than losses, then we're good. It's guaranteed that if dice A of I is greater than dice B of I, W plus plus. If dice A of I is less than dice B of I, L plus plus. So the greater die wins, right? Okay. If W is greater than L. Oh wait, return W greater than, return W is greater than L. Okay, so now, okay, that's the method for beats. So we have to read in, oh, it's not n, it's like this t value, which is weird. T for int test equals 0, test is less than t plus, like this for each test case. And then dice A for I equals 0, I less than 4, I plus plus. C in dice A of I, and then for int I equals 0, I is less than 4, I plus C in dice B of I. Okay, now for dice C, for what we're doing, I want to do int A equals 0, A is less, no, 1 through 10, right? Yeah, wait. Yeah. 1, A is less than or equal to 10, A plus plus. And then I have to do for B and C and D. For int b equals 1, B is less than or equal to 10, B plus plus. And then for int C equals, this is like a game, this is like type racer basically at this point. Oh no, I don't like how this, no, this space here. And then for int D equals 1, D is, I do put a space here usually. That means these are the ones that are, yeah, okay. Nice, fixed it. D is less than or equal to 10, C, D plus plus. Okay, so here actually there's a cool trick to know. So the dice 1 1, the dice 4 3 2 1 is the same as the dice 1 2 3 4 actually. Because it doesn't really matter what the ordering of the faces are. It's a dice anyways. You can rotate it and it's the same dice. And more importantly, for purposes of winning and losing, it doesn't really matter. So although the problem says like we should check like all dice even if they're not sorted, for brute forcing purposes, we can assume that they're sorted. So we can do this really cool trick. We'll do start B from C and start C from B and then start D from C. Make sure they're sorted. D from C. Make sure they're sorted. We can just do this because it's a lot simpler than like it's a lot simpler than it's a lot less cases than doing all of the transitions. But anyway, so after we set up this brute force, we can do this. Oh, can we do something crazy? Dice C at 0 equals 1. Dice C at 0 equals, this is like not crazy, but it's like really unintuitive. 0 plus plus. Dice C at 1 equals dice C at 0. I just gotta go through and fix this. C at 1 is less than 10. Dice C at 1 plus plus. And now this is dice C at 2 equals dice C at 1. Dice C at 2 is less than 10. Dice C at 2 plus plus. And then okay, so this should be the same thing. I just removed all the dummy variables. And after this inner loop, dice C should have the right values of our brute force. So first, if, oh, sorry. If beats dice A, dice B. So if dice A beats dice B, we'll just do this thing called the bool case. Bool A over B. We'll do that, I guess. A over B equals true. If beats dice B, dice A. So if dice B beats dice A, then A over B equals false. So now it's B over A. There's another case. So we'll actually make this else if, and then we'll do an else. So if none of the dices beat each other, so if A doesn't beat B, so let's say they're the same value, because they technically can be. If they're the same value, then wait, hold on. Wait. Yeah, if they're the same value, then like the output should be false because it's impossible to, because they can't be non-transitive. Yeah, no. And then break, I think. And this break will take me, I don't know where this will take me to. Well, this is not how you do strings too. No, okay. Where does break take me? What is this? Why can't I do this? Hello? Okay, that's fine. This break will take me back to the outside of here, which is good. And then if it doesn't break, so for each thing, if A over B, and then else. So this is the two cases to consider, right? So if A is over B, if A beats B, so A beats B, we have to beat A and lose to C. So if beats, we have to beat A. So dice C, dice A. And then we also have to lose to B. So dice B, dice A. No, C. How, yes. Oh, wait. Okay, so this is where, okay, labeled, hold on. Labeled. Wait, you know what I'll actually do? No, this is dumb. What I'll do is I'll do solve case. So do this instead. I think this is where, yeah, okay, perfect. Solve case. Instead of this, we'll do return. That's why that makes it easier. Okay, so we can put just call solve case, and then we can just do a return here, I think. Else the other case. It's a similar situation, but it's reversed. So we have to lose to A. I don't know why. C. We have to beat B. See out, yes, and then the last case is no. I think this is right. We'll run it and see, but I think this is good. Dig in there. It failed. What is the wrong with this one? Oh, I think there's an issue of okay. There's these problems here. We will deal with that. Hold on. Let's see. Because I had this error before. Copy these. Like I jump in here. Wait, then can I put them back? Back. Just build again. Does it work? Okay, build succeeded. Great. Okay, and then what is the input? It's here, right? No, that's not good. Okay. It just beats logic, right? See how. Check this. I'm sure this is right. A second to run apparently because that takes it forever. What the heck? Hello. Okay, I don't know what happened there. So in the first case, A beat B. Seems right. And A beat B, and then they lost. Okay. That seems right to me. Then I'll do for inside equals. I think maybe this brute force is wrong. Is 4x plus. Yeah. Let's see at 1 at I space. I'll do CR handle. Yeah. Okay. No, this looks right to me. Just tries every combination. Wait, so let me see, where does it start? 1, 2, 2, 2, all the way to 1, 1, 10, 1, 2, 2, 1, 3, 1, 4, 1, 5, 1, 5, 1, 2, 1, 3. Yeah, it looks right. Beats B, beats C, D, BC, 1. Does dice C beat A? C beats A. Wait, hold on. How's it beat A? So let's just hold on. Let me try something to see because 1 4 1 4 8 9 should win. Okay. So let's just do one. Control C. Okay, hold on. This brute force is working well. Let me just dice C equals, can I do this? 1 4 8 9. Okay. And then C out beats dice A, dice A, C out dice B, dice C. Okay. And this should, oh, I can't even, oh, that's sad. How do you, unassignable? Interarray, is that how you do it? Ugh, I don't know. Whatever. 0 equals 1, dice C of 1 equals 4, dice C of 2 equals 8, dice C equals 9. Sorry. 1 4 8 9, right? 1 4 8 9. Yeah. Okay. Oh, that's not the right input. Sorry. Sorry. Wait. Oh, it's okay. 0 1 no. Maybe and then do 1. Is this getting confused? No, we just have to do that. 0 1 no. Okay, to look better, I'll just do that one. Okay. So A indeed beats B, which is good. C beats A. Am I calculating the win percentage? Is this not the right way to do this? Because let me hold on. I gotta just calculate this by hand now. What time is it? How much time do we have in this contest? We haven't used too much time left. All right, so 4 5 6 7. 4 5 6 7. Oh, and I'll have to do this here. 4 5 6 7. This is the A, and then and then B is, C is 1 4 8 9, right? That's what I have it as, 1 4 8 9. 1, 8, 9. All right, so this is an L, this is a tie, this is a W, this is a W. 5, this is an L, this is an L, this is a W, this is a W. 6, an L, L, W, W. 7, L, L, W, W. So 1, 2, 3, 4, 5, 6, 7, 8. Should work. Right? How? No, this is why. Oh my goodness. How did I miss this bug? Okay. Let's try that again. Yes, no, no. Is that how you're supposed to do it? Oh, okay, great. Perfect. Okay. So now we have to just get rid of all these. Where else am I printing out stuff? I don't think that's it, right? No, no. Okay, okay. I think this is right. I'm gonna try to submit it. I think this should also run in time too. There we go. Cool. Wow, C++ is so lightning fast. It's like instantaneous almost. That's crazy. All right, okay. Non-transitive dice. So drought. A grass have dried up. Farmer John's pasture dried up. Use desperation of this Farmer John's comes to brilliant idea of purchasing corn. Was he not purchasing corn before? Oh no, he was growing grass. Okay, never mind. Okay, okay. And cows are arranged along to diet cows at hunger level. Okay. All cows social animals is eating together. The only way for them to decrease hunger levels is like 2 days cows feed them 1 bag of corn. Cause their hunger levels go down by 1. Needs to feed all their cows at the same non-like as possible. Okay, okay. They're arranged to set kind of. He selects 2 adjacent cows and feeds them each 1 bag of corn. Hmm. Do the hunger levels you want them to be equal? Hmm. Hmm. I wonder. What if I do this? Okay, okay. So I think for these type of problems, is a really cool trick because I really don't like the idea of like making them all equal because if I make them all equal, then for some arrays, then making them are you going to they're all I think for this problem, like I don't like making them equal because like it could be 4 4 4 4 or it could be like 2 2 2 2, right? There's like many ways to solve this. What I like to do is this little trick here. So I don't know if this will work. Hopefully it does. Take an array like 1 3 4 2 1 0, right? With these operations of decrement 1 to both things, what I really want is not for the array values to be equal. I can think of it like this: the difference between things to all be 0. So this difference right now is 2 because 2 3, right? This is 1. This is -2. This is -1. This is -1, right? So I have this array now, 2, 1, -2, -1, -1, right? Why is this different? Well, whenever I decrease two things by 1, what I'm doing is whenever I decrease two things by 1, right? Let's say I'm doing it. I mean, there's 3 cases to consider. Let's say I'm doing it from the middle of the array, right? So like I decrease these 2 by 1, right? This goes to 2, this goes to 3. This difference goes down by 1. This difference though goes up by 1. Like the difference between this difference stays the same, but this difference here goes from -2 to -1, right? So my operation of this array is like -1 + 1 like that, right? Alternatively, what I could do is decrease the middle, these 2 cows here, which means that this is just +1, or I could do this -1, right? So that's cool. It's really nice because I can kind of take this and almost slide it around to get what I need. Let me think. Hold on, is this good enough? Let me think. How I use it to solve the problem. Well, maybe this isn't super helpful. Never mind, I was just toying around with this idea. I don't know. I was thinking about this, but there's some weird thing you can do towards the end already. Kind of ruins it. What other way can I do this? I'm trying to think. It's actually such a hard problem. I feel like it's kind of hard to. It's not straightforward like the other two. So I realized that for the even numbers, something you can do is if I want the minimum number of bags of corn to feed his cows, right? So you're right where your operations are. Hold on. Let me go back to this difference idea. 2, 2. That's not very clear either. Hold on. Just think. Maybe I also need to take a break because it's been a while. Let me just think for a bit. If we know what the target hunger level is, the problem is really easy. I don't know if it's easy to find out what the target hunger level should be. An n squared solution. Wait. There's only one input case where it's that big. I can solve all of these ones with this, I think, right? Or no, I can solve all of these, I see. Hmm. I feel like there's a trick that I'm missing. Like I want the solution to solve tests like 2 through 8. I feel like I can just do that first. Yeah. So first take. Oh wait, hold on. I'll do this. Hold on. This is wait. This is empty. It should be empty. Okay. This is the new problem. That's all right. Okay. Now we can get rid of this. We'll make this. Yeah. Also, there's a test case amount. Oh, I want to do a similar thing actually, where it's like solve case and do each case, I think. That's a nice structure. Suit T. This case. Zero, I plus plus plus. I'll just do Cn I. Let me just do solve case. So solve case assumes that hunger I have been filled out, and then what we'll do is here for int h equals 0, h is less than 100, h plus plus. So for each possible height, I'll just do h guess, right? Plus plus plus. Okay, that's weird actually. Okay. For min h, let's do this for int equals 0 less than I We'll just do this. Just for safety, long h equals 1. I guess I'm not this. H guess less or equal to. Long. And then I. So equals. So worst case, it's 10 to the 9th times 10 to the. It's like 10 to the 9th times the 5th thing. So 10 to the 14th. We'll do 10 to the 15th to be safe. 7, 8, 9, 10, 12, 13, 15. I don't know if that's enough to recount. Should be enough. Put it all here. All right, so that's the answer. Current equals 0. And current, so just do current here. Current plus or equals. The idea is kind of like for every guess of what the true age is, I compute an answer. Yeah. Wait, sorry. So current plus or equals the hunger of I. So hunger of I minus H gas. We have to feed that cow that many times, and then we have to do. Just hunger of I minus H gas. That's how many times we feed it. Something I'm missing here. It's something really obvious I'm missing here, but I'm gonna think about it in a bit. Oh, and then equals. Advance is still this high, hasn't gone down. Let's try if this works, and then we'll try to figure out a smarter way than brute forcing it, but it should work. Oh shoot. Okay, -1, 14, -1. Wait, 0, -1, what? Something's up with the way I wrote this. Jessica CNN, you see in hunger by solve cases. So what did I return? -1 for the first one? Let's guess. Where's one that I can easily solve? This is right. Hello? Okay, wow. Okay, so, oh, pause this, whatever. And then this is, yeah, manage. Sorry, I'm doing it too fast. Okay, okay, build succeeded. Okay. The min-h seems to work fine, yeah. That's good. And then what else could be wrong? Does not work. Let's go down 5 times. This is built up at 2 actually. I'm gonna try. Jesus is so hard to parse. Actually, we'll just do 1, 8, 10. Oh wait, sorry. 8, 10, 5. 5, 2. Wait, what is this? Oh, okay. Yeah, it should have worked. What in the world? Oh, it did up at 14. Nice. Okay. Does it work? 14, 10. Excuse me, how do you find 10 for the second input case? Manage ends, currents, it's reinitialized. Hunger's reinitialized. No, you're find something better than the best solution. 2. What is this? 6 4 6 4 4 6 4 6 4 4 6 4. Oh, something's leaking because it does it right when it. Oh, it finds another. Yeah, here's the weird part. How's it able to get 3? And 2 -1. Oh, wait a minute. It's able to. Okay, okay. Well, it can't be negative. Yeah. Oh, I see. Because it's able to get negative. That's why. Um. Do this, I guess. Score underscore. Huh? Is this the point of failure? Oh, unterminated conditional directive. Sorry, that's how comments work in C++. Wait, what? What is going on here? If I go start at 3, does it work now? Like, what's going on here? -128, -1. What in the world? There's some annoying bugs going on. Bad day. It's because located under. Is this the reason? No. Oh my goodness, this is a really bad reason. This is dumb, but again, this is the brute force, so we're gonna resubmit something after this. Because I don't reset. Ugh. Copy it to make sure I don't overwrite this, and then this is hunger. Copy, hunger, copy. Hunger, copy. Okay. -14, -1, -1. -1. Alrighty, I'm not proud about this, but it's brute force. It's good for partials. Good to do. Just to make sure we have the problem correct. Should get up to 8, and then it should start failing. Yeah, okay, perfect. Okay. So at least we know the brute force. How do you do this in a smart way? The brute force takes advantage. It's O of n if you know what H is, but how do you know what H is? Is there any smart way to get H? Like, eight, 10, 5. You can make like 5, 5, 5. There's something that I'm thinking. I wonder if there's an easy way to find H. Maybe we deal with it differently if H is odd or even, like 8, 10, 5. There has to be some way to make this easier, right? I mean, I wonder if what I was doing before worked, like where it was like, you look at the differences. Seemed like maybe it was gonna work. What is wrong with the? This is really interesting where like this is even a case, unless we go to 100. Maybe I should take a break because it has been like an hour, so I'm probably tired. I'm just gonna rest, just like because I think this is all like honestly pretty good in a contest to take breaks. So yeah, I'm gonna rest and just come back to this, and I feel a little bit more clear-headed. But yeah, it was a brute force. We just have a few more cases to get. We just have to hunker down and get this done. But yeah, this is a hard problem, I think, for especially for prompts. All right, okay. I'm back. I think maybe this idea is better than I thought. Like, okay, if you make this difference array, like let's say differences are 2, 1, 2, 3, 1, 2, like with spaces in between. Like here are the actual values. Here's the difference between the two things, right? So this is the difference I was telling you about. For this 2 right here, we need to get them all to 0. So we have to do I think wait, when you do a -1, this difference gets subtracted by 1, this difference gets added by 1. Okay. So when you do this subtract operation on if you you want to get this difference changed, right? The only options do -1 plus 1. So you have to do like a -2 here to get this to equal to 0. So you're locked in. You have to do that, I think. Right? I don't think there's any other way to change that difference amount. Yeah. And what that does actually is now you can look at this one. The only way to alter this value is to, hold on. Yeah, the only way to update this value, because now this is +2 because you do -2 here. So now our total is 4 chords. Okay, let's do this as an example, okay? Let's do this 4, 4, 6, 4, 4. Okay. So 4, 6, 4, 4, 6. Wait, hold on. I'll do the bottom 4, 6, 4, 4, 6, 4. This is 2, this is -2, this is 0, 2, -2. Okay. So for this 2 here, you have to do let's see the totals. You have to do a -2 here and a +2 here. To get this to be 0. So now we're at 4. And then for this, no, this is different because you can use this operator, you can use another operator. Now look at this one, right? The only operation you can use to change this +2 value is to do a -2 here, and then a +2 here. So this gets to 0. And then still non-trivial. We have these like values left here. I guess maybe this makes sense because this is like now 4, and this is like a +2. This is like a -2, so it's +4 and then +4 again. This is 16. I wonder how to handle the odd and even because I think this probably works better for odd numbers cases. But yeah, it seems like it works. Actually, so like the idea is this, right? Like so you have these the odd, and so this one right here can only be changed. So this is locked in place. Now 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 this is locked in place, right? That's the idea. If it's even though you have these things, and the issue with this is that this is not locked in place. It can move around as much as it likes. Minimum. But let's say, I mean, let's do the case where it's odd, right? So if it's odd, the difference, the difference array is even. So if it's even, this is locked in place, right? And then this gets locked in place, and then this right here gets locked in place, and you use the free variable to finish it off. Oh, and then you can do the same thing on this end. You go this, and this, like this is locked in place, this is locked in place, this is locked in place. Yeah. So that's the odd case. That actually, we solved the odd case in O of n. The even case is still pretty hard. And then for the odd case, it's impossible if the values get negative. I don't know, this seems like too weird and janky of a solution for a bronze problem. I'm also trying not to rely on any like silver techniques. I also noticed that if it's even, if the array is like an even array, if I can make 6, I can definitely make 5 happen too by just decreasing by 2 everything here, and I can make 4 happen, so on and so forth. I think for odd cases. Actually, even case might lend itself better to technique. I know. So using evens, I could do something called binary search, where I know that it's like solvable, 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 unsolvable, unsolvable, unsolvable. So instead of scanning through all of the values, what I'll do is I'll pick a value, check if it can be solved with that value. If it can be solved, then I update my range of possible values to here. If it can't be, then I know that the thing I'm looking for is in this range. So I can do binary search if it's even, but I wonder if it's odd. Can I do binary search as well? Five minus 5 minus 5 minus 2 minus 2. I'm trying to make it equal to 2, 2, 2. So it's minus 6 minus 6. Let's do 5, 3, -5, minus 2. The best solution would be -5, -2, -2, 3. Yeah. Cha-ching. Versus 4, 8, 10, 5, 2. What would happen? Maybe odds I can use another method to do. Zero, I have what? So if you color the entire grid black and white, this is like a trick from like math competition. You color black and white like this. I'm just trying to find ways to think about the problem that's not like limiting to what I've already done. Worst case I can do like kind of a janky solution that combines like I think it might be a silver topic, but I'm really not sure. But so you have the 0 squares and the 1 squares, right? The sum of the 0 must equal sum of the ones. And the reason why is because when you do a decrement operation on two things, you're decrementing a 0 and a 1. So you're never like this like sum 0 minus sum 1 needs to always be equal to 0 from the beginning. And if it's not, then you know that it's impossible. Yeah. That's a good way to test for impossibility, I think. And then I think I just H. Wait, if it's odd? Wait a minute, hold on. Something's not checking out. Hold on. Ah, jeez, what the heck is wrong with my? Wait a minute. Because for this input, the sum 0 is not equal to sum 1. Oh, right. Okay, because at the end. Oh, if it's odd, we can solve this instantly, I think. Oh, we can find h instantly, I think. So the difference between sum 1 minus sum 0 needs to be h, actually. Because if it's odd, right? Oh, so this is one of the problems where you have to break into odd and even cases. If it's odd, the difference between sum 1 and sum 0 needs to be equal to h because they divide by 1 square. So for this problem, you know, it has to be 3. For this problem, it's -1, which is why it doesn't work out. And then for these problems, for this problem, I think it's also -1. Wait, no, it's 10. Yeah, it should be 10, which is too big. So for odds, you can figure out what h should be. You don't have to try all of them. For evens, it's hard to figure out what h should be, I think, because this trick doesn't work anymore. So for odds, you can figure out what h should be. Yeah, okay. I'm gonna make a method here that's like long test h guess. And then in here do this. And we'll do we'll make this an isolated method. So long current equals 0. Copy array and okay, chill. Yeah. Good. Just want to make sure this runs the same on the inputs. Oh shoot, didn't watch. Hold on. 14, 9, 16, -1, -1, -1. Yeah, perfect. Okay, so this is still valid. So I'll just make two separate methods actually. So call solve odd all the time, and then solve for solve odd. We know the answer is odd, so we do for int I equals n plus plus 0 h if I mod 2 equals 0. Oh wait, hold on this. And then we'll just do this. So if I mod 2 equals 0, h plus equals to hunger of I minus equals hunger of h h h. Okay. And mod 2 equals 1. Solve odd. Let's solve case. Is solve case brute force what I just do solve brute force? Yeah. Let's just try this, see if it works. So for all the odd problems now, I'm 16, really? What? 0, 16, 16, -1, -1. What? What in the world? What's going on here? This should not be. Let's see how h equals. Oh, Drew's it didn't attach. H equals 3, h equals -1. Wait, h equals 3. You got 0? That doesn't make sense, actually. Do I not ends equals h. What? First. Okay, let's just chill. Okay, cool. Did 14, 16. Oh, if h less than 0. Yeah. Oh my goodness, no, that's not how you, hold on. That was dumb. No. Let's just do that. There's no need for else here now. Okay, we don't have to do this anymore actually too. All right, let's turn this in and see if it gets more cases right. And then we'll do the evens separately. How are we doing on time also? I should check. Oh, we have like 2 hours left. Okay. So I should get up to, get the odd cases, I think. Yeah. Now to do the evens. Okay. So it's a little bit different for the evens. How do you do that? How do you work the evens? How do you find out what the H should be? And if we deduce what H should be, it helps us a lot. So the evens doesn't change. Yeah, because for the evens, actually, there's no one working H, you just need the biggest H. I think you can do this thing called binary search where, so we'll start out with like, we want to try to basically, so all the H's span from 0 to 10 to the 9th, right? So this is our low, this is our high. We're gonna guess in the middle here, midpoint. And then if this point works, that means like there might be some point above it that also works. So we want to set low equals mid. And if it doesn't, so if we try mid and it's not able to solve it, that means that the actual point is below us. So this is 0, this is 10 to 9. This is called binary search. You can learn more about it. I don't know if it's a bronze topic. I really hope it is, but I can't really think of any other way to solve the evens. But basically, oh no, I spilled water on my touchpad. No. Okay. But basically, I think using binary search will help us a lot in the even cases. So we'll just do that. So yeah, like you're gonna guess and update your guesses. Okay, so anyway, I'll do low equals 0, long low equals 0, long high equals 1, 2, 3, 1, 2, 3, 1, 2, 3, and then that's fine actually. While low high and then long mid equals low plus. So wait, I'm either gonna break it up into, so if I have a guess sheet of size 3, wait, sorry, guess sheet of size 3 or size 2. Oh, size 3 I'll do. This is mid, low, high. Just do some base case like exercising for myself. It's either gonna be here or it's gonna be here, right? So I think it's either gonna test mid up, it's either gonna result in mid up or below mid. So that means what I need to do is I need to round up because for the 2 test case, I need mid to be here. Test here versus here. Yeah. Mid plus high plus 1, 2. And then answer is test H mid. If and equals low less than mid. Low I can make -1 actually. If answer equals 10 LL, okay. Mid else. Test H low. So I'll just do solve Go back and check that this is the. Huh? Well, okay, I'll just test them real quick. This is 2. This is 2. That works actually. This is 0. This is 10. The binary search doesn't work. Mid equals this. Mid equals -1. It'll never equal -1. Answer equals test h. Mid if answer equals. Let's try this as a test. Answer equals 10,000. Wait, if answer equals 10,000, that means it's too high, which means high equals mid -1, else low equals mid. I think it might have gotten these messed up. Okay, let's try that. Replace. I got 16 correctly. This needs to be -1, and then this needs to be. And then this can be deleted. Not correctly. Oh, sorry. Low plus high plus 1/2. It should never trigger the increase one. What? High equals mid -1. I could just do, hold on. This is easier way to handle this, actually. Just use this stuff. There's no H here, actually. Should work, okay. Oh, wrong input, whoops. Okay, yeah, that works. And also, I don't need to print out this anymore. Please. Okay, I think that works. Let me just submit it. It's kind of janky. I don't like doing I'm feeling bad about using binary search in bronze, but I think there's a chance it might be a bronze topic, and I really can't think of any better way to do it. It looks like that's correct. All right. Okay. So that's it. We're done with the bronze con. It's really hard this year. I think honestly, this problem, once you realize the odd case, even cases about just knowing binary search, I wish there was a better solution I had, but it is what it is. Yeah, so that's it for today. I got nothing else for you guys, but thank you so much and hope to see you guys in the silver contest soon.